This question is about the chemistry of the elements in Group 2 and the halogens. Part A. A student prepares an aqueous solution of magnesium chloride by reacting magnesium with excess hydrochloric acid. Write an equation including state symbols for this reaction and state the observation or observations the student should make whilst carrying out this experiment. Firstly, we're going to write the equation with the state symbols. So our equation, we're preparing magnesium chloride, which has the formula MgCl2, and we're reacting magnesium with excess hydrochloric acid. So our equation, we're going to have Mg, or magnesium, which is a solid, with hydrochloric acid, which is aqueous, and we're going to produce magnesium chloride, so MgCl2, which is aqueous also. And then we're also going to produce a hydrogen gas. And finally, we need to balance the equation by adding a 2 in front of our hydrochloric acid. In terms of the observations, because we've got gas produced, we're going to see some effervescence. But we need to say our second observation is that the solid is going to dissolve, the solid in this case being magnesium. To get the mark for this question, or the 2 marks, you get 1 mark for the correct equation and 1 mark for both observations, so you need to have both to get the mark. Part B. Lattice enthalpies give an indication of the strength of ionic bonding. How would the lattice enthalpies of magnesium chloride and calcium chloride differ? Explain your answer. This question consists of 3 parts in order to get the 3 marks for this question. So the first reason why the lattice enthalpies of magnesium chloride and calcium chloride differ is because magnesium chloride has a more exothermic lattice enthalpy than calcium chloride. So this statement gets you your first mark for this question. And then your second reason or mark is because magnesium 2+ as the ion is smaller than calcium 2+, and so for your third mark, the attraction between magnesium 2+ and Cl- or chlorine minus is greater, so this gets you your third mark. So the breakdown for marks is first stating that the magnesium chloride lattice enthalpy is more exothermic, your second mark from saying that magnesium 2+ ion is smaller, and then your third mark is from saying that the attraction is greater between magnesium and chloride ions. Part C. The table below shows the enthalpy changes that are needed to determine the lattice enthalpy of magnesium chloride. Part 1. On the cycle below, write the correct letter in each box. Okay, let's start with this arrow. So what's happening is magnesium plus gas is going to magnesium 2+ gas. So what this is called is the second ionization energy of magnesium, which is here, and so we can label this as F. Then we can look at the next arrow below, and what's happening is magnesium gas is going to magnesium plus gas, which is the first ionization energy of magnesium, and so we can label this B. Then if we continue down and look at this arrow, what's happening is magnesium solid is going to magnesium gas, and that's called the atomization energy of magnesium, which is E, and so we can label this E. Then looking at the next arrow down, we've got magnesium solid and chlorine gas going to magnesium chloride. So these are the elements in their natural forms going to this compound, and what that is the formation of magnesium chloride, which is D, so we can label this D. And finally, looking at the arrow on the right, well, we've got our ions of magnesium and chlorine, and we're forming our magnesium chloride. And what this is called is the lattice enthalpy of magnesium chloride. So that's letter G, so we can label this as G. To get the 3 marks for this question, you must have all 5 letters correct. If you have 4 correct, you get 2 marks, and if you have 3 correct, you get 1 mark. Part 2. Use the Born-Haber cycle to calculate the lattice enthalpy of magnesium chloride. The method for this question is that we're trying to work out this arrow, but we can't do that, so we're going to have to work around by going all the way round and using the information that we do have. So if we're going in the opposite direction to the arrow, the sign needs to flip. So for example, we're going to have minus 2 times minus 349, minus 1450, minus 736, minus 2 times 150, and then minus 76, minus 642. We've kept the minus 642 because it's going in the right direction. And if we type this into a calculator, we get minus 2,506 kilojoules per mole, which is going to be our answer for this question, which we can then write on the answer line, minus 2,506. So what I've done is I've filled in the missing information on this Born-Haber cycle. So that was the first electron affinity of chlorine and the atomization of chlorine. And because there are 2 chlorines, I've multiplied both of these numbers by 2, and then we've worked our way around to get our answer. To get the 2 marks for this question, you must have minus 2,506 written on your answer line, provided with the correct working out. Part D. Describe and explain the relative reactivity of the halogens chlorine, bromine and iodine in their redox reactions with halides using reactions on a test tube scale. Include reaction equations and observations in your answer. Firstly, let's write the reaction equations. So our first equation can be between chlorine and bromine ions or bromide ions. And we're going to produce bromine, so Br2, and chloride ions, so 2Cl-. And what we're going to produce is a yellow solution, and this is our observation. Then we can write our second equation, and that will be between chlorine and iodide ions, so I-, and that's going to produce iodine, so I2, and chloride ions, or 2Cl-. And our observation will be an orange or brown solution. So now we need to comment on the trend of reactivity. Whenever you talk about trends, you need to talk about the direction. So we're going to talk about and focus on the trend of reactivity down the group of the halogens. As you move down the group, there's more shells of the halogens. There's also increased shielding. And with more shells and increased shielding, it's more difficult to gain an electron. So these are the 3 bullet points that we're going to talk about when talking about relative reactivity. And because it's more difficult to gain an electron, we see the reactions happening the way they do because the chlorine and the bromide ion wants to give its electron to the chlorine to make the chloride ion because it's easier for the chlorine to gain an electron. To get the 6 marks for this question, you must describe and explain concisely the trend in reactivity of the halogens. This is the 3 bullet points in this question. And describe and explain full observations of redox reactions backed up with at least 2 equations. So here we've got our observation next to our respective equation.